got two dice. If I roll the first, then roll the second, what's the probability that I get 2 3s? You should think that through. But probability 2 3s and 2 rolls is 1/6, which is the probability of a 3 on the first roll, times 1/6, which is a probability of a 3 on the second roll. The probability is 1/6 on both rolls because the 2 rolls are independent. I'm rolling 2 different dice. The result of the first die has no effect on the result of the second. So we have the independent events, we multiply the probabilities. So the probability is 1 out of 36. We can see that in a number of different ways. One way is by a tree diagram. We can draw the tree, and of course I haven't drawn the whole tree. I've drawn the 1, 2, 3, 4, 5, 6, the possible events on the first roll, and then off of each of these I've drawn, well, off of the 1 here I've drawn the 1, 2, 3, 4, 5, 6, the possibilities for the second roll, and I've numbered them. I can't do that in the space we have here, but I've drawn kind of a little fan coming off of each number, so you know what that represents. Same thing we have up here. It's the numbers 1 through 6. And we can see that there's only one way that we can get 2 3s. We've got to get a 3 on the first roll and then a 3 on the second roll. So that one possibility out of the 36 possible outcomes is the one that satisfies the condition, so that we don't necessarily have to use a rule for independent probabilities. We could have used the sample space represented by the tree diagram. Alternatively, we could have done a grid table of possible results, 1 through 6 here, 1 through 6 here. You know, I'm not sure why it says 6 5 down here. Put them in order. It should be 5 6. I'll leave it like that. It's not incorrect this way. It's just not in a very predictable form. So it's better if I had the 5 6. Well, we see that there's only one event out of the 36 possible results that has a pair of 3s. So again, there's 1 out of 36 probability. Okay. Now we go to the question: what's the probability of getting 2 5s on 3 rolls? Okay, this time we're rolling 3 dice, and we want to know the probability of getting exactly 2 5s on 3 rolls. So how are we going to analyze that? It would be impractical to try to draw the tree diagram and a grid. We'd either have to do a 3-dimensional grid or 6 copies of this grid, one corresponding to, say, 1 on the first die, so that the 2 outcomes you get here would be the second and third. That's just not a practical way to approach the problem. We can visualize that, but it's not going to be very helpful. So how do we analyze it? Well, what's the probability of getting a 5? The probability is 1/6 each time we roll the die, each time we roll a die. The probability, well, okay, to get 2 5s on 3 rolls, one way to do it would be to get a 5, then a 5, then something besides a 5, okay? So we get a 5, then a 5, then a not 5. What's the probability of getting a 5? Well, it's 1/6. Probability of getting a 5 on the second roll is 1/6, and the probability of getting not a 5 on the third roll is 5/6. If the probability of getting a 5 is 1/6, then the probability of not getting a 5 is 5/6. We multiply that out, and we get the probability of getting a 5, then a 5, then not a 5. Of course, that's not the only way we can get 2 5s on 3 rolls. We could have gotten a not 5 in the first roll, then the 5, then the 5. That would be different. Okay, that could happen, and the probability turns out to be the same when you multiply it out. The not 5, of course, is a 5/6, and that goes first, then the 1/6 for the next 5, then the 1/6. But multiplication is commutative and associative, so when you calculate this, you get exactly the same thing you get when you calculate this. Okay, and it's also possible to get the 5, then the not 5, then the 5. And the probability is as you see here. So there are 3 ways to get 2 5s on 3 rolls. And each of those ways has a probability that is a product of 1/6 and 1/6 and 5/6. Maybe in a different order, but it's still the same 3 numbers. So the probability would be 3 times this. I will go on with this on the next clip and bring this into some kind of formal analysis.